Hello there and welcome to another Unity tutorial. In this tutorial we're going to do another little extension on the first person player controller that we've written in previous tutorials. So I've got a copy of it right here, and we can sprint just like we could for our last tutorial regarding this component, and then we've got everything else like double jump. I'm jumping pretty high at the moment though. Anyway, so you might have noticed that with the jumping, with the way that we've set this controller up, if the character hits something above them, then this happens. Hang on, then this happens. It kind of like floats underneath, right? So there's no head detection. And that's what we are going to be doing in this video. So this project just uses, like I said, the player controller script that we've created over previous tutorials, and the mouse look script that we've created over those tutorials as well. So for the modifications we need to integrate, we need to open the player controller script from the project window in Visual Studio. Okay, so here's the script. So the first thing that we're going to need to do is create a new serialized private variable. So this one will be a serialized field private float, and we'll call it head detection range, and I'll give it a default value of 1.5f. And that's the only variable that we're going to need to create for this very simple functionality. So the next thing we want to do is scroll down to our update method, and we're going to do this in the first if statement within that update method, the one that checks if canMove is equal to true. So it doesn't matter whether we're grounded or not, we're going to run this every frame. So what we're going to do is we're going to draw a ray from the player's position in the up direction for a certain distance, the distance that we just defined in that variable. And if that ray hits anything, we essentially want to invert our velocity, so we start traveling, down instead of up. So we'll open an if statement here. And now we're not specifically going to use a raycast here. We're going to use a variation called a spherecast. And we can access that by saying if physics.spherecast, and we want to check the result is equal to true, right? So this is the spherecast method here. First, we're going to pass it the position to start drawing the ray from. So we just say transform position to pass it this object's position. Then we need to pass it a radius. Now I'm going to pass it the radius of the character controller itself as the radius, because that's the radius of the collider associated with the controller. So we can access our controller variable and then radius. Then after that, we need to pass it a direction. Now we always want this to check directly up, right? So we'll say vector3.up is going to be our direction. Next, we need to store a raycast hit inside a variable. Now we don't need to do anything with the thing that we hit with this raycast. We don't actually care what we hit. It's not going to change how our head detection works. So we can create a discard variable here. So this is going to be an out raycast hit. And to create a discard variable, we just name it with an underscore. And the compiler knows that this variable is meaningless. We don't do anything with it. So it'll just discard that via the garbage collection. Lastly, we pass the range or the distance for our spherecast, and this is going to be our head detection range. Now, if this is equal to true, right, we want to check if our velocity is greater than 0. If it's greater than 0, it means we're traveling up still, right? Now, if it's greater than 0, what we're going to do is we're going to say velocity is equal to 1 divided by the negative version of whatever our current velocity is, which will give us like a fraction, and it'll be negative, which will cause us to start moving downwards. Now, believe it or not, that's all we actually need to do for our head detection. But just to help us with debugging when we're setting up the head detection distance, we'll add a gizmo that gets drawn in the scene too. So we'll scroll down to the bottom of our script, and underneath our apply movement method, we'll inherit the onDrawGizmos method. Now here, I'm just going to set the gizmo color to red by saying gizmos.color is equal to color.red, and then the next gizmo that this method draws will be drawn in red. So here we're going to draw, what will we draw? We'll draw a wire sphere, right? Now we have to pass this two things. The first thing is the center. So for the center, we're going to say transform.position plus vector3.up multiplied by head detection range, right? And that's going to place it right at the center of our head detection distance, basically. Then we need to pass a radius to draw the sphere at. Now, for this functionality, I actually use the character controller's radius, but that won't work in all scenarios here. Say when we're not in play mode, there is no character controller reference in the controller variable, right? So we need to pass it a different value in that case. So we can pass it, we can kind of create like an inline if statement here and pass it one of two values, right? So what we're going to do is we're going to say controller not equal to null followed by a question mark, right? So this here, everything before the question mark, this bit here, this is the condition that needs to be met, right? So if this condition evaluates to true, it means that there is a character controller, right? In which case we can happily pass it controller.radius. Okay. Now we need to give it another option in case controller is equal to null, right? So if it is equal to null, it's going to pick the right hand side of the colon that I just put in there, and we'll just say 0.25f and then close the line. So while we're not in play mode, the sphere we're drawing here, this red sphere, will be drawn at a size of 0.25 units. But as soon as we hit play and this controller variable gets set within the awake method, all of a sudden this condition here will evaluate to true because controller will be not equal to null, and we'll be able to use the radius of the controller with no worries at all. So with all of that done, we should be able to save the script with Control S and head back into Unity and test this out. Okay, so I'm back in Unity now. Let's just select our player controller in the hierarchy. And we can see there's a new variable here called head detection range. And if we move that, we can see the red sphere in our scene view here moves up and down as well, right? So I might just leave this at like 1.5. And let's hit play and see what happens. Okay, so if I jump now, you can see also as soon as the game started, the radius of that sphere got larger as soon as the reference to the character controller was made within the player controller script. But yeah, so now if, yep, we're underneath. So if I jump now, you can see as soon as we hit it, we get, well, our velocity is inverted and we're pushed down towards the ground. So now we have head detection. So that's it for this tutorial. Nice, quick little simple one showing you how to implement head detection for this character controller we've created. If you found this video useful, please leave a like. And if you want to see more game development tutorials like this, then I'd encourage you to subscribe to the channel. Thanks for watching. Have a wonderful day.